Welcome back to Let's Talk About Data. This week, we're diving deep into unsupervised learning, a powerful approach used to discover hidden patterns in data without labeled outcomes. In this episode, you'll learn what unsupervised learning is and why it's important, clustering and dimensionality reduction techniques, algorithms like k-means and PCA, and how to implement clustering with Python. If you're learning something new, don't forget to like, share, and subscribe. Let's explore the hidden structures of your data. What is unsupervised learning? Unsupervised learning means the model is given unlabeled data and its task is to find patterns, structures, or groupings. Examples: customer segmentation, topic modeling in NLP, market basket analysis. Key concepts: 1. Input features only, no labels. 2. Pattern discovery and grouping. 3. Common tasks, clustering and dimensionality reduction. Clustering techniques. K-means clustering divides data into K-groups based on feature similarity. Centroids, distance calculation, iterative updates. Hierarchical clustering builds nested clusters using dendrograms. Agglomerative versus divisive methods. Dimensionality reduction techniques. PCA, principal component analysis, reduces the number of features while preserving variance, helps in visualization and speeds up model training. t-SNE, great for visualizing high-dimensional data in 2D/3D, applications of unsupervised learning. Real-world use cases, recommendation systems, Netflix, Amazon, market segmentation, anomaly detection in finance, document clustering, news or research papers. Now, let's dive into the code. We'll start by loading our dataset, exploring its structure, and preparing it for clustering. Then we'll apply the k-means algorithm and visualize the results. To keep things simple, I've prepared a Jupyter notebook with all the steps, and you can follow along by downloading the dataset and code from the description below. This dataset contains customer information from a mall, including customer ID, unique ID assigned to each customer, gender, male or female, age, customer's age, annual income, $, the annual income in thousands of dollars, spending score, 1 to 100, score assigned based on spending behavior, importing necessary libraries. Loading and exploring the data. Here's a glimpse of our data. We'll focus on annual income and spending score to perform clustering. Visualizing the data. This scatter plot shows how customers are distributed based on income and spending habits. But we need a way to identify clear segments. Finding the optimal number of clusters, elbow method. Before applying k-means, we need to determine the optimal number of clusters, k. We use the elbow method. This graph represents WCSS within cluster sum of squares against different k values. The elbow in the curve indicates the optimal k value, usually where the drop in WCSS starts slowing down. In our case, the elbow appears around k equals 3 or 4, so we'll use k equals 3 for better segmentation. Applying k means clustering. Now, each customer is assigned to one of 3 clusters. Let's visualize them. Visualizing the clusters. Each color represents a different customer segment, and the yellow X marks the cluster centroids. This segmentation helps businesses tailor marketing strategies to each group. Wrap-up, and what's next? Summary. Unsupervised learning equals no labels, just patterns. Key techniques: clustering and dimensionality reduction. Useful in many domains, from marketing to security. Next week, we're diving into model selection and tuning. Stay tuned for week 8 on Let's Talk About Data.